All right, good afternoon. We are going to look at Learning Target 7, where we are going to calculate enthalpy changes using enthalpies of formation, which you've looked at before when we did the bonds broken minus bonds formed learning target number 5, I believe it was. This is going to be a really similar process, but we're just going to use a different set of data in the data booklet. So after this video, you should be able to calculate the enthalpy of a reaction, and more specifically, one type of reaction, the enthalpy of combustion reactions. So let's get started. So calculating enthalpies of reaction. Definition: enthalpies of formation is what we're going to use here to calculate the enthalpies of reaction. And they are defined as the thermal energy that occurs when 1 mole of a substance is formed. So we use the symbol delta H sub F with a little degree symbol, where that delta means change, H sub F means heat of formation, when we're forming different compounds. And that little degree symbol means that this data was taken when the temperature of the surroundings was 25 degrees Celsius or 298 kelvins. So that's when you see these data points with the little degree symbol, that's what that means. So what do you need to do this? Again, you're going to need your data booklet. So I'm going to click on this really fast. There's that data booklet again. And starting about page 15, and you'll notice here you first got your bond enthalpies, which we did Learning Target 5 with. But now we're using table 12, which starts on page 16. And you've got all of these substances here, and you're looking at the fourth column, the enthalpy of formation column in kilojoules per mole. So that's what you're going to need there. You need this formula, which is very similar to the Learning Target 5 formula, but slightly different. So the change in enthalpy of formation of products the enthalpy of formation for a reaction can be calculated by doing the sum of the change in enthalpy of the products minus the sum of the change in enthalpy of the reactants. So take a moment, please write down this formula. And you might want to make a note here. This is where you use table 12. Use the table 12 values here. Another important thing to note, this is not the same formula as the enthalpy of formation can be calculated by using bonds broken minus bonds formed. It uses different data. The one from Learning Target 5, which is the one down here in red, used your bond enthalpies data. Your answers that you calculate for both of these formulas will be very similar, but they're going to be slightly different because the bond enthalpies are based on average bond enthalpies, and that doesn't take into consideration overall intermolecular forces or other temperature changes. So you can use these two to get very similar answers. They're two different ways of getting your change in enthalpy of formation for a reaction, but the answers might be slightly different. Do all substances have a heat of formation? For our intents and purposes, nope. We're going to assume that all the elements have always been present in the universe and therefore did not need to form. Is this technically true? No, because everything formed from the large Big Bang and we ended up making elements from that. But for our thermodynamics unit, this is the assumption we're going to make. So all elements will have this value. The change in enthalpy of formation at standard temperature is going to be 0 kilojoules per mole. This includes your diatomics. So have no fear of ice cold root beer. All of your diatomics are molecules, but they're also considered elements. All of these will have the enthalpy of formation change be 0. It takes no energy to form these things. So, what we're going to do next? Time for an example problem. What I'm going to show you in the next video is how to calculate the enthalpy of reaction, which is going to be a combustion reaction. They basically run the exact same way when 0.76 grams of benzene burns in an excess of oxygen gas. I would pause this video here and roll down to the next video that you will find on the assignments page. Thank you very much.